Hey, good afternoon. Or good morning still. Can you hear me? Can you hear me back?
Take the microphone.
No, the other one. The other one on the.
Coming.
Maybe.
You want me to
Yeah,
use one?
yeah, that one too.
Okay.
No, yeah.
Hey, dude, can you hear me? Nope. No, there it is. Oh, there we go. Hello. I mean, that worked. That worked. Can you hear me now? Okay. I guess I'm using this one then. Hello. I'm here to talk to you about Hadoop, PHP, and Symfony. Very quickly, who am I? So this is an ugly photo of me. That's my name and my Twitter handle. If anyone wishes to tweet abuse at me or constructive feedback, I'm up here, so I can't defend myself for an hour. So go right ahead. I work for a company called Symfony. We do lots of buzzwordy type stuff with internet measurement data like machine learning and big data and all of that kind of jazz. If you are from London, come chat to me about a job maybe. If not, I can still tell you what you do. It's interesting. I also am on the management team and core development team of a project called PHP, which you all probably used about 25 years ago. However, it is modernized now. It uses Symfony components. If you want to chat to me about that, then do. Or Niels, who used to be our lead developer, is also around somewhere. And I'm also one of the FIG, PHP FIG secretaries, so standards organization of PHP. If you want to have a chat to me about that again, come on later. But you don't care about any of that. You're here to talk about something else. Now, there was a talk this morning by Nicholas, and he came up with this slide.do thing. It seemed like a really cool idea, so I quickly made a modification to my slides. And if you have any questions throughout the talk, if you just stick them on there, then we've got them at the end. It's quite a technical talk, and there's a lot of stuff to do, so yeah. C617 on slide.do. So, Hadoop. This is a Hadoop logo. What is Hadoop? Has anyone used Hadoop in the room before? Okay, like 4 people. Good. So Hadoop at its core is a suite of applications by the Apache project. It initially started quite a long while ago. I've got some dates in a little bit. And the idea of which is that it would provide a suite of different projects, and there's lots of different projects that make up Hadoop. It's not like one core thing. But it's for distributed systems. So whether or not you're storing your data in lots of different, on lots of different servers, or whether or not you're distributing your processing of that data, or even if it's just about handling redundancy and making sure that your data is duplicated, and if one server dies, then you're fine. Hadoop is really great at all of these things, and there are lots of different packages that do different things. It's quite often associated with big data. Now, I really, really hate buzzwords. I did a talk earlier on this year about how much I hate buzzwords like big data. Because the chances are is that none of you actually have big data. Google has 15 exabytes of data. It's like the estimate. So if you maybe have 15 terabytes, you have a millionth of the amount of data that Google does. You don't deal with big data. I don't deal with big data. None of us do, unless you work at Google. Anyone work at Google? Okay. So none of us deal with big data. But the point of Hadoop is that big data is not just an amount of data. It's a series of problems. It might be that your data is unstructured. So for example, you're dealing with Zendesk tickets, or you're dealing with lots of free text on a survey website, for example. It may be that you're just simply struggling to fit all of your data on one particular machine. Sort of trying to find a machine that has over 4 terabyte or whatever hard drive is quite expensive. So maybe you just want to be able to distribute all your data across a bunch of different machines, your log data or something like that. So the chances are most people in this room actually have some kind of big data problems, but they don't feel willing to use big data technologies because of they don't feel they have big data. So it's all about distributed applications, not necessarily big data. So I like history. Who likes history? Oh, good. So Hadoop. where it initially came from. So in 2003, Google released a paper called the Google File System. And this was very similar to a POSX file system, but it was distributed amongst a whole bunch of different servers. It sits at a different level. And then in the following year, they announced a paper called Mapreduce, which was about data processing, again in a distributed fashion. Now, these two papers were Google's way of handling large amounts of data, right? But because they released these papers to the public, of course, someone else decided to sort of try and come up with their own implementation of this. And Google internally have their own implementation of both of these things. It's not Hadoop. A couple of years later, Hadoop development begins. It was initially used by Nutch. Does anyone remember Nutch? It was like a search engine? Okay, a couple of people. So it started at Nutch, and then he moved to Yahoo, and Yahoo were like, let's open source this stuff, because Yahoo was actually quite a cool company. And it was named after a toy elephant. That's where the name Hadoop comes from, and why the logo is an elephant. It was like a plush toy that was I think it was the founder's son's toy, and they couldn't come up with a better name. So Hadoop does things fast. When you throw lots and lots of servers at a problem, it really helps speed. So in 2006, when Hadoop was sort of beginning development, it could sort 1.8 terabytes in 48 hours. Now, the speed in which you can measure like a terabyte or an exabyte or a petabyte or whatever of data is like a common usage to sort of show how you can handle large amounts of data. So if we go forward to 2007, we could sort 1 petabyte in just 12 hours. So we could suddenly start sorting basically 1.25 terabytes per minute. That's ridiculous improvement in just 1 year of development. Take it forward to 2008, we could do it in half the time. That's cool. Keep on going forward, 2010, suddenly we can do it in just a couple of hours, 3 hours. And this trend continues to the extent where we stopped having to measure it like just 1 petabyte and started having to talk about 50. Now, the most recent number I could find for how quickly to sort like a series amount of data from a reputable source was 50 petabytes in 23 hours. So it's like 40 terabytes a minute, which is huge. Now, I don't have like a 500 node cluster to like sort this like ready to go, so I can come up with a more up-to-date number. But you can see how quickly and how exponential that changes. So it's lots faster now. And in 2014, there was a project called Spark, which allowed Facebook, I think, ran the numbers on this, and it allowed them to sort 5 times more data with 10 times fewer nodes. So it saved them money and it had a speed increase. So Spark will vastly exceed all of these numbers. So I mentioned that Hadoop is like a series of different components, but what actually are some of those most common components? There are 4 that are kind of their core. We've got Hadoop core, which is just like some core libraries and stuff. It's kind of a framework bundle. You've got Hadoop Hdfs, Yarn, and Mapreduce. Now, Yarn and Mapreduce, I'm not going to say too much on. Like you could do an entire talk on each one of these topics, but I've got a lot to talk about. So I'm just going to say very quickly, Yarn is for resource management across a cluster, saying give this server lots of work to do. It's like not really using many of its resources right now. And Mapreduce is a way of breaking up much larger processing tasks into smaller tasks. So it breaks up into 2 different stages, a map stage and a reduce stage. If you have 150 documents and you want to count the number of times the word "the" is in these documents, what would happen in the map task, for example, is it would count each individual document the number of the words "the." And that would be, and then so the end of the map task you have 150 numbers, and then the reduce task would basically just add all of those numbers up together and give you your total as to "the." And what that's allowed you to do is instead of running like document by document and counting all the instances of the word "the," you've actually split that into 150 different tasks, which can all be run in parallel and don't depend on each other. So suddenly you can process things a hell of a lot faster in a distributed manner. There's loads of other tools. I'm not really going to talk too much about most of them. Hive I'm going to talk quite a little bit about. That allows you to use Hadoop as a relational style database. BigTop, if any of you want to go home and try this, then BigTop allows you to like really quickly set up a Hadoop cluster and like virtual machines on your laptop. You can have your own like 10 machine virtual cluster on your laptop running in about 10 minutes using Docker, Vagrant, tool of choice. There's a bunch of other stuff which I'm not actually going to talk about. So, what I am going to talk about. First of all, I'm going to talk a bit about Hdfs, how the data is like actually stored. This is the storage layer. I'm then going to talk about Hive. Hive is a very well-known relational way of sort of structuring the data and allows you to use it as a relational database management system, which is actually quite tongue twister now, I say it out loud. And we're going to be using that for writing our data. I'm then going to talk about a tool called Presto, which is a library by Facebook that allows us to read data from Presto. I'll go into a bit more what that means in a minute. Presto, which is Presto PHP put together. Great naming, I know. I'm very proud of myself. My mum's proud of me too. A library to make Presto accessible from user land. It just like, I'll talk more about that. And then finally, how we integrate this into Doctrine and into Symfony, right? Cool. So Hdfs. The way Hdfs works is that you have lots and lots and lots of something called data nodes. And these nodes contain all of your data, as kind of the name implies, right? So you might have like 100 of these, you might have 600 of these. And you scale this out as much as you like. And then you have one name node. Your name node basically just contains the metadata as to where all of the files are located. So it's like, you would talk to it and say, hey, where is /var/foo.txt, and it would then tell you like where this was located on all different data nodes, and then you talk to the data nodes. So that sounds not like a single point of failure, right? You've got your 600 node cluster and one machine has a disk failure and then suddenly root. So very recently, and like scarily recently, considering this has been a massive single point of failure that could cost your company like billions of pounds, I'm English, hence pounds, not dollars. They added the ability to have high availability and failover, which is cool. But you also have like a restriction in that your entire metadata of your file system needs to be able to be stored in memory on your name node. Your name node should basically be the most expensive piece of hardware you can realistically afford that will never ever die. Yeah. So how do you read a file from Hdfs? I've kind of already alluded. So you've got a client library, your PHP application, for example, or maybe like a Mapreduce job if you're doing other stuff with Hadoop. And you've got your name node, your one name node. And you say, hey, I'd like files.txt. Yay. It will then respond back with essentially where the different, so each individual file is divided up into lots of little blocks. So if you have one 5 gigabyte file, it will be divided up into tiny little blocks, which will be about 64 megabytes each. Very similar to a normal file system, except it's a bit more obvious when you're distributing your blocks everywhere. And it will say, hi, I've got block number 1, block number 2. Block number 1 is located on these data nodes, and block number 2 is located on these data nodes, which are very happy and saying hello and waiting for you to sort of talk to them. A bit lonely. So I say to one of them, hey, can I have block number 1, please? And then he says to me about block number 1, symbols. And then I do the same thing to get block number 2 from a different data node. And I can then really easily recompile, and it's basically a calculation of the blocks. Yay, Hdfs. If you've got any questions, again, just like stick them on the slide.do thing. 216217, I think is the code. You'll soon find out. So Hive. How do we make this into a relational database? I know how to store files, like I can just do that in Dropbox, right? So what Hive actually gives us is, most importantly, is a metastore. So it will correlate, it will one structure the data on Hdfs into like directories and that kind of thing for you. It then provides a metastore, which is generally like a MySQL database. And what that MySQL database will tell you is how schema matches up to files on disk. So I can say, hey, this particular table cur_metric belongs in this particular table, this particular directory, these particular files, and then it will like detail things like partitions and stuff as well, and privileges and all that nonsense. I can show this to you super quick. I have a bunch of live demos, but a bunch of them require Wi-Fi, so we'll see how those go later. Yay. So I can't actually see this from here. So what table is this? Partitions, great. Something I wasn't actually planning on covering. So if I go across up here, DBs, wonderful, yay. Here it basically just details a bunch of databases. This is our development cluster at work, so don't worry about what the actual databases mean. Specifies where they are, and then if I jump over and show you the tables as well, I'm aware this is kind of small. So here, each row is a table, and it specifies kind of like the table details, like schemas to get installed elsewhere. But yeah, the point I'm just basically trying to make is that Hive is kind of just like a convenience layer that structures stuff and it stores it in MySQL. Cool. So, what are we going to use Hive for? Now, in our particular instance, Sam knows, we get all of our metric data coming into a data collection server, and what that does is it then just like generates some TSVs. TSVs are great, you can share them around, you can load them into lots of different data sources. They work for stuff. But they're not efficient to read from actually directly. You want to convert them into a better format. So we want to convert to a format called awk, which is a column-based format. So instead of having to read every single row of data, if you're only looking at like 2 rows, 2 columns, and there are 10 columns, it saves the amount of data you're having to read and process. And doing this is really simple. So here I'm saying, basically look through a directory, grab the file name, and then I use this particular command, which allows me to put a file into Hdfs file system. And this is just this would be my TSV file essentially. And I'm grabbing that from into temp on the Hadoop file system, sorry. So then I just simply, I load that data into a CSV table, into a TSV table, and then I simply select from that, and then insert that back into an awk table. And Hive just does all the magic of converting formats for you. So if the Wi-Fi works, I will do a demo. Which means I'm going to do this. Can you read that at the back?
Can you read that? Ooh, hello. Yes.
Hello. Oh, there we go. Oh, that was a bit loud. Can you read that at the back?
Yep.
Cool. So in my demo directory, what I'm actually going to do is I'm going to grab some data from MySQL. I'm going to put it into a TSV file. I'm then going to upload that into Hdfs, into Hive, and then I'm going to convert it to awk. So my data in MySQL is this. It's basically just a whole bunch of rows, randomly generated data with some dates and some values, completely random. So this is hard doing one-handed. Cool. So I'm just hopping onto a thing here, literally just grabbing a TSV with MySQL. Nothing really that interesting, actually. Yeah. So now we can see I've got randomdata.tsv in there. Wonderful. Don't judge the fact that the MySQL password is password. It's accessible only from localhost, right? Right. So what I want to do actually is I want to gzip this. Realistically, TSVs I'm only uploading them into Hadoop for very quick file access, for converting them to awks. So I don't care that they're slow to read. Meanwhile, I kind of want to save space on Hadoop because I only have 150 terabytes, and you can use that quickly, right? I mean, it depends what you're doing, but yeah. So I've just gzip that. So if I do ls with one finger, cool. Cool. So you can see that there. I'm now just going to shout at you for a minute because I can't actually type and do this.
So can you all hear me if I talk like this? Yeah. Okay, good.
So cat number 3. So this is the interesting stuff. What I'm doing here is I'm saying where that particular file is, and then what I want to do is create a directory in Hdfs. I'm then going to do remove everything in that directory at the moment because I'm overwriting all of that data. I could just, if I wanted to, insert new TSVs in that directory, and then it would just like append the data. I want to basically clear out what's already there. So essentially what I'm doing is I'm just putting that file, that .gz file, and I'm just putting it into Hdfs. It's kind of like SCP, but like to something that's kind of local, but not really. And Hadoop file system will handle all the kind of like stuff about where the name node is, where to put the blocks and stuff for you. And then what I do is I actually interact with Hive and I say repair the table. The reason I do that repair table is essentially it needs to know where the partitions are, and sometimes you might have changed the partitions, added new partitions and stuff. When it says repair table, it kind of implies something is broken. It's not. It's supposed to do that. It's just stupid naming. Okay. This takes a moment. All of that output you see there is basically related to the repair table. When I open that connection, it's got a beeline connection to Hive. It basically just throws a whole load of output. But most of that is that. So if I now actually hop into beeline, which is again how you sort of interact with Hive, can't see that. So I just opened the beeline connection, and if I now do select star from Hive demo, I think it's called, we can see that data has been inserted, and it just reads that straight from a TSV file. Very simply, all I've done is basically move a file, and it recognizes that it's there. But as I said, that's inefficient. We don't like that. So I've got this final file in here, convert to awk, and all I'm doing is delete the current existence of this awk file that's currently there. You can't do an insert into. You can't insert rows. You have to delete entire partitions and recreate partitions because of the way that awks or awk files work. So I delete from it, and then I insert it basically from the TSV version. So I insert to the awk table from the TSV table. And it just handles that conversion for me. Okay, now if I do quick query, what's it called? So now you can see that I've got all of that data in there. And that is as simple as putting data into Hdfs Hive and being able to take it back out again. That's kind of cool. Right. Cool, so that's that. So Presto, how are we going to read this data back out again? You kind of might have seen Presto mentioned in that last file. I kind of just like glossed over its existence. What is Presto? So Presto is a distributed SQL engine. Now what that means is it's not a database. It's not MySQL, it's not Postgres. It's just simply a way that you give it SQL and it knows how to then turn that into a way to get data. So there are a whole load of different connectors that you can do. So Hive is the one that we kind of care about and the one we're using. But I could also run a Presto query and it could talk to MySQL. Now in the case of Hive, it will talk to the files directly and do its own stuff. And just read from the meta store. MySQL, it will actually open a MySQL JDBC connection. And it really depends on a bunch of these. You can talk to Mongo, they've got their IPO today, congratulations Mongo. You can talk to Redis, so you can do a join. You can do a query to MySQL and you can join onto like your Redis data and your cache data, so you don't have to do two separate queries. That's useful. If you're doing testing stuff, you can get it from memory. Recently, I saw someone that posted a mailing list that they'd created a connector for talking to REST APIs. So you could run like SQL queries and it would end up talking to a REST API to get data and then return that back to you, which is just like really weird, don't ever do that. But you can do it, right, is the point. So how does it work? Your PHP application talks to something called a Presto coordinator, one single Presto coordinator detecting a theme in. And that Presto coordinator can then talk to a whole bunch of different workers. And those workers will do work. They will essentially process your query. The coordinator just simply knows where the data is located on your cluster, and therefore can like look at which workers are less busy and then sort of just like hand out the tasks. It's a resource manager more than anything else. And then these talk to Hdfs and your Hive meta store directly. They go and grab all the data, process it, etc. Now, you can actually expand out your coordinators. You're not really supposed to. It's kind of a bit of a like gray area. Like, if you can, if you should, you shouldn't really. Your discovery service, the way that the workers talk to the coordinators, it can only talk to one. But you can kind of balance your node scheduling, but you'll get a performance decrease in a lot of instances because it won't know how all the coordinators are, how all the workers are doing. The part you should scale out is your workers. We just added something like 10 kind of beefy servers to our development cluster like last week, and we were seeing gains of sort of queries that would originally take like 120 seconds were taking like 10 at this point. So, and it has a really cool UI too, because like who doesn't like a UI? Live demo number 2.
Sorry, I've got to like open this as it connects.
And very patiently wait for it to connect to London. Yay, there we go. Cool, so this is the Presto command line. From here I can just run some queries. So I can have a look at that data that we were just looking at. Oh, can you see that? Not really. I mean, to be fair, there's nothing interesting there anyway. So that was the data that we were seeing earlier. That was what I meant about my sort of sneaky jumping into Presto a bit earlier. But I can like process huge amounts of data really quickly. So I'm just going to run a query. So this is looking over quite a large amount of data. It does take a second. So that just processed in 7 seconds 4.64 billion rows and 11 gigabytes of data on a 6-node cluster, maybe. And they're not beefy, they're like quite low-spec machines, to be honest. It's a development cluster. Our production cluster would get a hell of a lot more. That's quite cool. Like, try doing that with MySQL and you would like, yeah, just tone. Not if you still want your sysadmins to like you afterwards. Yeah, it can process data super quickly. That's kind of as much as the Presto demo goes. But what I can do actually, so I mentioned that we've got a UI. There's like filtering and stuff up here, so you can see my colleagues like doing work on there at the moment. So I can just like jump into one of these, and it will give me details about the query as well. So here, for example, it shows me what all of the different tasks are. So it split it up into a whole bunch of different tasks and executed them on a bunch of different nodes in the cluster. And you can see the sort of different nodes here. And it gives you a whole load of stats. It's like how the query went. I'm not really going to go too much into this, especially seeing as my SSH channel's just dropped out. Oh no, reference back. So it'll show you like how the query actually ran as well, which is cool. Where are my slides? Your screen recording thing that died, by the way. Cool, so this is great, it's all theoretical a little bit, you can do it from the command line. How can we actually do this usefully? So Presto, that's the logo for Presto. We have a creative design team. It was originally like a database thing, and then I asked them to like do something with it and make a Presto logo, and they did this. So PHP, how do we react with it? So the actual way of communicating with Presto is through a REST API. So that like crap that I was giving to REST APIs earlier, like sometimes it makes sense apparently. So it was very simple, just like building a wrapper on top of this REST API, and so we did, and it's called Presto. And it's really kind of simple. So I can just open, specify like my host I'm connecting to, which is my coordinator. I can open a connection, and then I can just execute any query I like. Select star from table, and it will then just give me a result, which is great. It means I can communicate with Presto, and I can do some other things too. I can get like the status of the Presto cluster. I can get like how. So there's not if you're running like a long query, you can get like the status of the query as well, which is good for things like analytics dashboards, or if it's going to take like 4 hours. That's the library. So how does this all relate to Symfony? It's really simple to set up. So initially what we did is we were like, okay, we now have this library, let's integrate it to Doctrine. So we did. And it's as simple as sort of specifying a few sort of parameters. Your catalog is essentially what you're connecting to, so like Hive, MySQL, that kind of thing. Like underlying server that Presto connects to. The host is Presto that you're connecting to. And then you've got schema, which is kind of like, that's your actual database name. I can execute a query, and then suddenly I can start to use Doctrine usual kind of PDO type methods. So I can do a fetch all on it, I can do fetch and like loop through each individual row, particularly if it's like a much larger request. If you've got like gigabytes and gigabytes of data, you don't want to load that into memory, right? And we can load it into Symfony too, as a result. So obviously you would move this stuff into like your .env files or parameters.yaml or whatever. But you just simply specify a connection, call it whatever you like, and specify a driver class. If you specify this here, this is the fully qualified domain class name for the driver. We specify those same parameters that we saw up here. We specify a bunch of options, so like the source is coming from my MacBook, like that kind of thing. And then it just works. So I could have like a repository here. It's just sort of it's like any other service at this point. Throw in Doctrine, open a connection, run a query, and return the result. So that means that realistically, from inside of your Symfony application, you could be reading that 11 billion rows or 4 billion rows and 11 gigabytes of data in 7 seconds. That's quite cool. Cool, so that's Presto and Doctrine. Are there any questions? I can look at this thing. It works. Okay, I don't know how this works, so anyone who put a question on there earlier didn't work. Rude. I'll ask Nicholas after. Are there any questions? You can just like stick your hand up at this point. Technology failed us. Yeah, go for it.
Are you using Spark in your production environment, or is it just straight Hadoop?
Yeah, so Spark, I didn't talk about, I think, I mentioned it briefly at the beginning in terms of it's fast. Spark is a way of doing analytics queries, essentially, and interacting with Hdfs that way. It's really super quick. Yes, we do use it, as Sam knows, for a bunch of our analytics stuff. We use a bunch of stuff, a bunch of things. But yeah, so Spark is cool. It's definitely worth looking at. That book that I put up on the slide earlier, if you want to like learn more about Spark or Hive, Mapreduce, that kind of thing, have a read of that book. It's about this big, so you'll need to take like a week off work to read it. But it's worth it. It's a really good book and really useful. So yeah, go for it.
Yeah, well, you were talking as far as like setting this up, messing around with it. You mentioned Big Top.
Yeah, so
Do
actually
you
big
have
job.
any, like how I went to there, but do you have any like, you know, I don't know, links that you could put up there?
Yeah, sure. I haven't kind of got time now. I can tweet out like a link just afterwards, just like a specific thing to look at. They have documentation, I think, in their README, or maybe you have to like go into a directory. But basically, with like Docker or Vagrant, you can just like spin up a cluster of 3. But yeah, I'll tweet a link to like some docs on how to use that if you want. Cool. Any other questions? Yeah, Aaron.
Where's your hat?
In the bags next to that guy over there. But you're just trolling, so shut up. Yeah, go for that.
Have you used Elasticsearch with Hadoop, or would they be able to work together at all?
Yeah, so there's a bunch of stuff on the Presto users mailing list about this past couple of weeks actually. You can interact with Elasticsearch through Presto, basically typing in SQL query and then it will like map that to schema.
Oh, cool.
I'm not really sure, unless you're doing joins between like your Hive data or MySQL data and Redis data and your Elasticsearch data, I'm not really sure how useful that would be, because it would probably be more performant to interact with Elasticsearch directly. Otherwise, you've kind of just got this extra layer of uselessness. Like Hive is really useful for some things. For example, with the way that it processes like Presto is useful in the way it processes Hive data. MySQL and that kind of thing, it adds a little bit of overhead. So the only time it really makes sense to use that is when you're doing like grabbing data from MySQL to put it into Hive, or you're doing a join. Or you just want to simplify your code base and then you have one database connection and don't really care about performance. Because I've never done that before. Cool, I think that's everything then. Thank you very much. I'll put my slides on Twitter. Yeah.